Hello and welcome. So I'm going to begin by talking about how I started woodworking. I swear this is relevant. So I started woodworking in 2010. And when I was in 2010, there was this new blog that had come out, annawhite.com. And she was a woman in Alaska that gave out for free a bunch of digital woodworking plans. And so I saw these and I thought, this looks so cool. I want to try to build one of these. And the cool thing about her website was that it was very step-by-step. It wasn't filled with lots and lots of text, so you could just kind of follow it like a cookbook. Step 1, do this. Step 2, do this. And it came complete with like illustrations and stuff. It was amazing. So for my first project, I decided to build like this little shoe cubby thing. And as I'm going through the steps of my very first ever woodworking project, there was a line that said something like, attach these two pieces and check for squareness. So I pulled out my square and checked, and it wasn't square. And I thought, okay, now what? But the instructions didn't say what to do if it was out of square. And it didn't say why it was important. So I just said to myself, probably not a big deal. Actually, that is a big deal. Yeah, if you don't have square pieces in woodworking, yeah, it's not good. And then at the end of the day, when I tried to put the thing on the floor, it just rocked. That kind of annoyed me. Not kind of, it really annoyed me. And there was this little twist in it, and yeah, it wasn't good. So although it was like essential for me getting into woodworking to have that kind of step-by-step approach, because I get overwhelmed pretty easily, and it was nice to have something that's just step 1, step 2, step 3. So this cookbook approach, the step-by-step approach, is great for certain things. What it does is it reduces complexity into very simple steps. But in the process, it becomes very light in the why you're doing certain steps and very heavy in the how. And that can present some problems. As you're reading through these instructions, it's presented as if each step is equally important, when that may not be the case. There may be certain steps that aren't that important at all. And there may be some steps, like checking for squareness, that are super important. But you wouldn't know that because it's just step by step. So I made the mistake of just saying, I'm going to skip that step. Big problem. So that's one of the problems. And another problem is that if something goes wrong, what do you do? So if you're following a recipe and don't know how to cook, and then you taste it at the end and it tastes terrible, what do you do? I don't know. The cookbook won't help you. At that point, you need to step beyond the cookbook. And unfortunately, if you are limiting your knowledge to cookbook style learning, you're never going to get to that point. So why am I talking about this? Well, it's because the way that intro stats taught is very cookbook style. Most undergraduate stats classes are taught using cookbook style. What do I mean by that? Well, similar to the cookbook style of woodworking or cookbook style of cooking, it's very light on the why you do certain steps and very heavy on the how. So here's an example of a cookbook-like approach. We've seen decision trees like this all the time. How many predictors do you have? If it's 1, then you can ask, is the IV numeric? If it's yes, then it's regression. Then you can ask, is there 2 plus groups? If it's yes, you do an ANOVA. If it's no, then you got to ask, are there independent groups? If it is yes, then it's an independent t-test. If it's no, it's a related t-test, and so on and so on. Very cookbook style. But what happens if your data don't fit into any of those categories? What do you do? There's another common characteristic in stats textbooks that make them very cookbook. They actually do have like several steps of how you do a statistical test. For example, it might be 1, state the null hypothesis. 2, state the alternative hypothesis. 3, set the alpha level, which we typically put at 0.05. 4, calculate the test statistic, like a t or an f or a chi-square or something like that. Step 5, compute the p-value. Step 6, compare the p-value to the alpha level. Again, very step-by-step, and it seems easy at first glance, but it's actually not. And it's a huge disadvantage, and this occurred to me once, it's probably like 2017, 2018. I was teaching a stats class, and I was teaching about the central limit theorem. And to me, at least at the time, the central limit theorem was kind of a big deal, and I thought it was important that my students understand it. And so I explained the central limit theorem. I gave them a chance to ask questions. They asked questions, and I spent like the entire class period, like all 75 minutes or whatever it was, trying to explain the central limit theorem. And I looked at their faces, and they were just blank. And then I had one student raise her hand, and she just said, "Can you just show us how to calculate it? How to calculate the central limit theorem?" In that moment, I had a stats awakening. Stats Awakening. That sounds like a cool movie.
The Stats Awakening.
Yeah, I was like, whoa. The way we are teaching stats is wrong. And that's, by the way, how my curriculum was born. It stemmed from that one incident. Because what was happening was this student was so concerned about the steps that she was missing the big picture. And that's one of the biggest problems with how we teach intro stats, is that we teach it as if they are steps. And we have so many freaking steps that the best they could do, and these students are so overwhelmed, they're so discouraged, the best they can do is try to memorize the steps. And so if you try to introduce anything theoretical or anything big picture, they're just like, can you not do that and just tell us what the steps are? And so I am bold to say that anybody who takes an intro stats class, even if they get an amazing, excellent score, even if they're at an Ivy League university, they come out of stats knowing nothing about statistics. They might be really good at choosing the right test or calculating statistics or that sort of thing, but they know nothing about statistics. That's a problem. So let me just summarize. Why is cookbook stats bad? Primarily, it does not help you develop a deep understanding of statistics. A couple years ago, I had a conversation with a colleague who regularly taught intro stats. And her and I were talking about hand calculations, and we both agreed that hand calculations are dumb. Like, you shouldn't do hand calculations. And what she said to me was, what really, really matters at the end of the day, statistics is all about knowing which test to use. What? And this was very sad to me, that a very experienced teacher of statistics thought the most important thing about statistics was knowing which test to use. No, that is not the most important thing about statistics. The most important thing about statistics is being able to make sense of your data, not what test to use. And when you focus on the appropriate test, it blinds you, actually, from making sense of your data. Another incident. This comes from a friend of mine. He was in a meeting with several other faculty members where they had data for every single psychology undergraduate student. And they were doing some sort of an analysis looking at grades based on race and gender and that sort of thing. And they all said, okay, what test do we use? And my friend, bless his heart, did a total facepalm. He's like, guys, we don't need to do a test. Like, what do you mean? You always do a test in statistics. He said, no, we have the population. You only do statistical tests. You only do inferences if you're trying to infer the population from the sample. We have the population. We don't need to do any tests. And they're all at a loss of what to do. They're like, okay, so what do we do then? That's a problem. That several faculty members, many of which were very experienced in teaching stats, had no idea how to make sense of this data. Why? Because they had been so focused on cookbook statistics designed to test things. When you take this sort of cookbook approach, especially if it focuses on tests, it robs you of the opportunity of really understanding statistics at a deep level. So another reason why this cookbook style is bad is that if something goes wrong, you're screwed. So it's kind of like that example where I talked about checking whether something is square. The instructions never tell you what to do if it's not square. Like, how do you fix it if it's not square? And likewise, in stats, very often these textbooks say, oh, we make the assumption of normality or heteroscedasticity or whatever. But what do you do if that fails? The textbooks don't tell you. And I think a final problem with the way that this cookbook style is that it really pigeonholes the type of research you can do. Because sometimes you're in a situation where you're trying to ask a question that does not fit into that decision tree. As an example, when I was a graduate student, I was a nerd, and it was time for me to buy a new car. And I went online, and there's something called data scraping where you can go to a website and have a program extract all the data and put it into like an Excel spreadsheet or something like that. And so that's what I did. And so I had data from like 10,000 cars within, 100 miles of my house. And what I wanted to know is which one of these cars is going to give me the best bang for my buck. If you give that to somebody who is a cookbook stats teacher and a cookbook stats learner, maybe even they've been teaching stats for 30 years, they're going to have no idea what to do with that. Because they're going to try to fit that research question into a test. Well, there is no test. So what did I do? Well, I built a model trying to predict the price of a car from the miles driven, the year of the car, the make, the model, all those sorts of things. And then what I did was I tried to find those cars with the largest outliers, the largest negative outliers, or in other words, those cars that were way underpriced given their specs. And I found 3 cars, and I went to all 3. And the first one didn't have an engine. Second one looked like it had been used as a punching bag by the Incredible Hulk. And I don't remember what was wrong with the third one. Oh, that's why they were so underpriced. Ha! So then I went to a dealership near my house, found the van that I wanted, and saw the listed price. I think it was like $10,000 or something. Then I went to my computer and looked up the price of that one vehicle and found out that that $10,000 was about average. And then I figured out, all right, what would be a good negative residual? And I said, all right, I'm going to offer them $8,000. So I offered them $8,000 and they took it. And I knew it was a good deal because I'd built this model. Now, of course, I could have used Carfax or something like that, but this is way cooler. But the point is, in this specific situation, my question could not have been handled using cookbook stats. So if you're trying to answer a question that is non-standard, you're going to be in trouble if all you've had is cookbook style statistics. And I've had this situation. I've had people consult me and ask me questions, and I'll say, whoa, that's a cool question. And I've never heard somebody ask that before. Let me think about that. Because you're not going to find the answer in a textbook. But what often happens when people don't have the experience is they try to, again, pigeonhole their research questions into the stats they already know. So maybe somebody doesn't know how to do a regression, but they know how to do a t-test. So what are they going to do? They're going to take the independent variable and split it in half, or do a median split. So this is exactly how bad practices are born, is that somebody who doesn't know what they're doing, who has only been taught cookbook stats, doesn't know how to approach the problem, so they make something up, and then everybody else says, hey, that sounds like a good idea, and then they do that. And then somebody like me comes in and says, hey, this is a very bad idea. And then they say, that's how everybody does it. Yeah, well, everybody's wrong. And it causes me to be frustrated. And I don't like being frustrated. So I hope you get the point. This cookbook approach is bad. Another reason it's bad is it gives you the illusion of knowing what you're doing when you actually don't. Because think about it with cooking. If you follow the same recipe 100 times, you're going to be pretty confident you can make that dish. But again, what happens if you run out of butter? Which leads me to my last point. It makes it impossible to adapt. So if you've been taught this like sequential step-by-step, you got to do this step, then this step, then this step, you're locked into those steps. And it makes it impossible to adapt, which is kind of related to some of the other points that I already said, but I'm going to say it differently anyway. And so just to go back to a cooking example, I actually like to cook, and I'm pretty good at it. And about a week ago, I was making beef stroganoff. And then the very last step was to add cornstarch to the dish. Now, I didn't have cornstarch, and I wasn't in a position where I could get it quickly. So what do? If you're just following the recipe, you're stuck. You have no idea what to do. But I know something about cooking. I know the purpose of cornstarch is to thicken it. And so I sat there saying, I know why that step is there. I need to thicken this thing. I don't have cornstarch. How else can I thicken it? So I thickened it using a roux. Because again, I knew the theory behind that specific step. If you don't know the theory or you don't know the reason why there's a step there, it makes it impossible to adapt. So if we have been shooting ourselves in the scientific foot for years, what is the alternative? That is a fine question. Well, if the old way is very heavy on steps and very light on theory, maybe we can reverse that. And that's exactly what the new way does. We're very heavy on theory and very light on steps. So instead of this massive decision tree, we instead do something like this. We specify the dependent variable, and then we specify the independent variable, and then we fit a model. Then we evaluate the model. Hey, that's easy. And it's also very easy to explain why we're doing all those things. And then we evaluate the model, like with visuals or estimates or model comparison metrics or something like that. And it's very easy to understand why we do each of these things. Or if you want another kind of like step-by-step, it's kind of funny that I say steps are bad, but they're not bad. I guess I call them, instead of steps, they're like guidelines. And another approach you could use is in a paper I wrote called the 8 Steps of Data Analysis. And here I am like contradicting myself. I say I'm anti-steps, but then I wrote a paper about the 8 Steps of Data Analysis. But it's very heavy on theory, very light on steps, I guess. Anyway, moving on. So let me just actually back up. Maybe I should have put this at the beginning of the video. Why am I talking about this? So I'm talking about this because one of the recent videos I published was about it's like a stats rant or something like that. And I was venting about the fact that so many people think they're experts when they're not. And in the comment section, there was somebody who said something to the effect of, if you want to be an expert in stats, it starts with linear algebra and calculus. And somebody disagreed with that, and I also disagreed with that. Kind of. I kind of agree, and I kind of disagree. And so I started thinking about that. Like, do you have to have a strong mathematical background to be an expert in stats? And I think my answer is no. And let me give you like an example. So when I was a undergraduate preparing to go to graduate school, I ended up taking graduate level stats classes. And the stats instructor, very nice, Santa Claus-like old man, very enthusiastic about stats. And he had this very strong opinion that in order to understand statistics, you have to do all the calculations by hand. And so this was a multivariate stats class, so he's having us do factor analysis by hand. What? Yeah. And so I found myself in the same situation that my student years later would be in. That I was so overwhelmed with all the steps to calculating it that there was no way that I could understand the big picture of what was going on. And to me, becoming an expert really comes in layers. So I think being able to do those calculations by hand is a critical step in becoming an expert, but it's not the first thing you should do. I think the first thing is that you got to understand what you're trying to achieve. And in statistics, what you're trying to achieve is you're trying to fit a model to data. And if you don't even know what you're trying to achieve, there's no point in doing hand calculations because you don't know why you're doing it. So you got to understand what you're trying to achieve. Again, fitting a model to data. So that would be the first layer of understanding. The next layer of understanding, I think, is you got to understand why you're trying to achieve that. So going back to what are we trying to achieve? We're trying to fit model to data. Why are we trying to do that? Because it allows us to uncover patterns in our data. And once we understand the patterns in our data, we can then use that information to form conclusions or to make predictions or that sort of thing. And then what? Once you understand the what, once you understand the why, then you got to understand the how. And this has 3 levels. By the way, I'm making all this up, but it seems to make sense in my head. So there's 3 levels to the how. The first level is in software. That's where you should start. So you know what you're trying to achieve, you know why you're trying to achieve it, and now you go into software and actually do it. So maybe you're in R, or maybe you're in JASP, or God forbid, SPSS. And there are a lot of statisticians out there that limit their abilities to this. But they're good statisticians. But if you really want to deepen your understanding, I think the next step is to understand the algorithms behind the statistical procedures. Or in other words, if you really want to deepen your understanding, you want to know what the computer is doing in the background to fit that model. And this is one of those instances that when you know that, you can understand why something fails. And this happens, like, for example, all the time with mixed models, that you get convergence failures. What is a convergence failure? Well, in order to know what a convergence failure is, you have to know what the algorithms are doing. And if you want to deepen your understanding even further, then I think then we get to the mathematics, the linear algebra, the calculus, that sort of thing. So in some ways, I think this guy is right, or girl, I don't know, or non-binary, whatever. Eventually, if you want to be a real expert, it is important to know the mathematical foundations of why you're doing what you're doing. So if you are in the software level, you're probably going to be a really good consultant. You're going to be able to do a lot of statistical analyses for people, and it's going to be great. And you can be an accomplished statistician. Great. If you master algorithms, then you're at the position where you can actually invent your own statistical procedures. And I did a lot of that sort of thing in graduate school. And it's fun. And if you really want to be a top dog, again, mathematics. And if you've got that level down, then you're kind of unstoppable. Again, it empowers you to invent your own algorithms and your analyses and that sort of thing. And it's kind of bragging rights. I remember the first time I used calculus for an actual research problem. I was so proud of myself. I printed off my proof and framed it on my wall because I was a nerd. I'm still a nerd. And let me just give you an example of how this all played out. So when I was in graduate school, I was doing a research project that required me to use factor analysis, and something wasn't working. I was getting some unexpected result, and I could not explain why it was happening. And I realized somehow that it had something to do with what was happening with factor analysis. And so what I ended up doing was I decided, you know what, I need to figure out why this is going on. So I completely rewrote the algorithm for factor analysis from scratch. And in the process of rewriting that algorithm, it was like a total light bulb moment. I was like, oh, that's how factor analysis does it. That is so cool. And it was also one of those like, wow, I've arrived. Because I don't know about you. I mean, you all probably have the same feeling, but particularly in graduate school, I had a lot of imposter syndrome. But at the end of that day, I could say, I reconstructed a factor analysis algorithm. I was dang proud of myself, I'll tell you what. So to summarize that point, I guess, like, what does it take to be a stats expert? It depends on what kind of stats expert you want to be. If you want to be an expert at analyzing data, I think you're fine just sticking to software. If you want to be the stats expert that is able to invent your own procedures, then you at least need to have an algorithmic understanding of what's going on, if not a mathematical understanding of what's going on. So yeah, it depends on what kind of expert you want to be. So now I'm going to put on my teacher's hat. What am I trying to teach my students to do? I do want them to be... I mean, it would be nice if my students were experts, but they're probably not going to be able to get there, just because I don't have them for that long. But I want them to be competent. And what I strive to achieve is what I call the Google point. And I don't know if I've ever talked about this on YouTube, but hey, here it is. So the Google point to me, I'm pretty sure I invented the term the Google point, and it is the point at which you know enough to be able to Google your question. So I don't know if you've ever started a new hobby. Like I remember this happened with welding. I started welding several years ago, and I knew so little. I didn't even know what terms to use to search when I had a problem with welding. I was like, there's lots of things that spread all over the place. Like, how do you Google that? There's things that spread all over the place. And then I learned, that's called splatter. How do you reduce splatter when you're welding? And I want the same thing for my stats students, that they can take the information I have given them, and it's not going to prepare them for every possible data analysis scenario they could ever find, because that's impossible to do. But instead, it arms them with enough knowledge to be able to at least ask the right question. So let's say you're saying, all right, I have a repeated measures data set and a binary outcome. How do I analyze that? Well, if you have some background, you can say, all right, repeated measures. Because there's repeated measures, I probably need to do a mixed models. And I've got a binary outcome. So that probably means I'm doing a generalized linear model. So you might ask Google, hey, is there such thing as a generalized mixed model? And how do I fit one of those? You're at the Google point. You can do that. And so again, there's no way I could teach my students to become experts. But I could teach them the path that they need to take to become experts. I can give them the Google point. And to get there, you cannot do cookbook statistics. You have to know theory. You have to know modeling. You have to know what you're trying to do and why you're trying to do it. So let me conclude with some recommendations. So what do you do? How do you how do you become an expert, and how do you stop doing cookbook statistics? And I guess the first thing I would do is stop doing hand calculations. Of course, if you're a student and your teacher's making you, that you're kind of stuck. But if you're a stats teacher, do not require your students to do hand calculations. It's ridiculous. Why would you do that? We have computers. Like, being able to compute things by hand is a totally different skill set than being a good statistician. So why in the world are we teaching somebody? Why are we trying to teach them two skills at once? And I would say the same thing goes, and this is going to sound weird coming from me. Do not try to teach them R at the same time you're teaching them statistics, for the same reason. Because learning R in computer programming is a different skill set than is doing statistical analysis. And I learned that the hard way. Like, the first several semesters at my university, I tried to do both. I tried to teach my students R at the same time I was teaching them stats. And it just was not working. And so I restructured things, so now that there's like a dedicated R class before they even get to stats. So they've already learned how to use R before they get to the stats. My third recommendation is to teach from the perspective of models, not tests. Tests are useful in some circumstances, but what really matters is being able to fit a model. Because when you fit a model, you can do tests. But you can also make predictions. You could also calculate residuals. You can also evaluate the fit of the model. You can evaluate assumptions. There's lots you can do with a model that you can't do with a test. And by the way, this a lot of this video is based loosely on a paper that I've written that is going to be in a book, but I will link a copy of that in the description if you're interested in reading it. Maybe I'll end up doing a whole video on that paper because it's kind of a cool paper, I think. Of course, every paper I write I think is cool. Whether it actually is or not is a different story. And then my final recommendation for how to get away from cookbook statistics and how to start walking on the path to expertise is to take a class from me. Yeah, you knew that was coming. Because we all know how corrupt I am and that I'm only doing this to make money.
Now wait a minute. Aren't all your videos free on YouTube?
Please sign up for a class and make me filthy rich. And coming in less than 3 weeks, we have another live simplistics class. So if you want to start from the basics, my intro to stats class, which I call simplistics, then I invite you to sign up at simplistics.net. And I'll leave a link in the description to sign up for that class. And in that class, you get to meet with me via Zoom and ask questions directly of me. Isn't that cool? And that is going to be on Monday afternoons, late afternoons, for the entire month of November. And again, I'll leave a link in the description so you could get more details there. And if you can't make that specific time, you could, of course, suggest time, or you can take my non-live class, or you can kind of do it at your own pace. So you get access to my Canvas course and quizzes and discussion boards and that sort of thing. And so you still get to interact with me, it's just not live, because you're posting questions on the discussion board and that sort of thing. I really hope to see you there. And I would love to see you there. And as always, I appreciate it because this does support me and encourage me to continue to make videos for you. And I look forward to meeting y'all in digital person, I guess. Anyway, peace out.